think you'll have to start.
So welcome everyone to Machine Learning and Friends Lunch. Today we're going to welcome our first ever overseas speaker. Professor Luciana Benotti is joining us from Argentina, where she's an assistant professor at I don't know why I wrote assistant. It says associate, and I wrote the wrong one. Sorry. She's a professor at the National University of Cordoba. Professor Benotti has received awards for her work on conversational interfaces and AI-based technology for education. Her research interests are in different aspects of situated dialogue systems, including the study of misunderstandings, clarification requests, and grounding. Today, Luciana will present her work on two different types of grounding and dialogue. Please feel free to unmute and welcome our speaker.
Well, thank you.
Also, just logistically, during the talk, feel free to unmute and interrupt with any questions that you might have. Thanks.
Yeah, please do that. As I was talking with Neha, I really like dialogue, so I like when people just ask questions. Thanks again, Neha, and thanks Kalpesh, and in particular, thanks Javier for making this possible. I'm excited to be able to interact with this amazing group and a bit anxious too. So as Neha said, I will be presenting today two types of grounding in dialogue. This joint work with a lot of people that I collaborate with. Some of them are my PhD students, like Mauricio Masuecos. And also I'm collaborating with people that have PhD students, like Alberto Testoni. I collaborate with Rafaela Bernardi from the University of Trento. She has also Agata Mercante, that is her student. And I also supervise Tobias Bianchi. Claudio Greco is from Rafaela's team. And I collaborate with Patrick Blackburn in Roskilde University in Denmark. So the basic premise of this work with this group of people is to ask in what ways, so this is like the big question, the big picture, in what ways we should be looking at language grounded in the world in order to try and feel that our dialogue systems can actually commit to the things they say. So let me move to the second slide. Somehow my presentation was doing weird stuff. So this talk is based on these two publications that you can see here. The first paper, we published it at a workshop at the MLFL 2020. That is a specific workshop for spatial language. And it proposes a simple transformer architecture for the task of referential visual dialogue. This is a traditional empirical paper, like the ACL papers or ACL workshop papers that you might find. And the second paper that I'm going to talk about here today is not an empirical paper. It is an opinion paper, a position paper and an opinion piece on the state of the art of grounding in dialogue systems. So these are two very different works. The one is more traditional ACL work, and the second one was kind of an experiment after 10 years of doing reviewing for ACL and being an area chair for the area of dialogue and interactive systems. I felt that somebody needed to write something in this direction. So it will be my first time presenting this paper. And I will be doing it with you now, and I will present it next week at EACL. I'm excited to see what kind of interactions and feedback from the community I get. Also, I wanted to mention that at EACL, I'm organizing a social called Latinx in NLP. And if you are attending EACL, please feel free to join. It's not only for Latin Americans, it's also for other people that feel that diversity is important. So we welcome everybody there. And we will have roundtables on ethics for NLP. low resource languages and discussions of the challenges that researchers from Latin America face. Also, we have some people joining in previous socials from Africa, so that we share some of the challenges of being in the global South. So just to start, let me pose a very general question and maybe controversial according to our reviewers about natural language understanding in general and dialogue systems in particular that give the big picture behind this work. So in 1991, Susan Brennan asked, why is it that natural language has yet to become a widely used modality for human-computer interaction? Almost 30 years later, the Vries and colleagues asked the same question again in a paper that was published at EMNLP. The second question here is triggered by Emily Bender and Alexander Koller's claim that human analogous natural language understanding involves mastery of the structure and use of language and the ability to ground it in the world. This claim is part of their position paper that got the Best Paper Award at ACL 2020, and that started a lot of discussion around whether these large language models were what we needed for natural language understanding. Here in this talk, I focus on the question about what does the ability to ground it in the world involve? So this talk is organized in two parts, as you can guess from the title, and as I already said regarding the two papers, corresponding to two different types of grounding. With Neha, we were talking about the different meanings that people associate to the word grounding, and that many times is used as a synonym of anchoring. Here I will be talking about two particular meanings of grounding. One is about perceptual grounding, and the other one is about collaborative grounding, although there may be other meanings. I'm not claiming that these are the only two meanings for the word grounding. So let me start right away with perceptual grounding in dialogue. As I said, this part is based on this workshop paper, and it explores one of the questions behind our research here is to explore why different kinds of visual questions may be more or less difficult for different machine learning models. In particular, we focus on spatial questions that are the ones that the workshop was about. So here we see an example of referential visual dialogue. And in particular, in this part of perceptual grounding, I will be talking about this kind of dialogue, referential visual dialogue. So reference is the process by which two people agree about something in the world that they are talking about. It can be a concrete object, like a table, or it can be an abstract concept. In referential visual dialogues, like this one that we see here, the referent is a concrete object, like the sandwich that we see in the photo. The person here, one of the person talking in the dialogue, we call it the questioner. And in this case, it is a restricted kind of referential visual dialogue because the questioner is restricted to asking questions. And the oracle, that is the one that knows what object he has in mind, can only answer with yes or no. Using this setup, a restricted setup of referential visual dialogue, a data set called Guess What was developed. Guess What contains 150K dialogues grounded on MS COCO images. The oracle knows the identity of the referent, of the target object, which is marked in green in the image. And the questioner has to find out which is this object among all the objects that are in the image. So here the questioner asked, is it a vase? And the oracle answers yes. The target, as I said, is in a green box in the image. So the follow-up question is it partially visible? The answer is no. The third question is it in the left corner? This is a spatial question because it is about the position of the target in the image and not some characteristic of the target itself, like the fourth question, in which is it the turquoise and purple one that you can that you could answer just by looking at the crop of the target, let's say. The position you cannot answer just by looking at the crop of the target. So most previous work on this data set was about replacing the questionnaire with a machine learning model. However, in this work, we focus on the oracle, not on the questionnaire. The questionnaire the questionnaires that are the state of the art right now use an oracle that makes quite a number of errors. And one of the motivations to focus on the oracle was to try and have a system that can answer better the questions for the questionnaire so that the questionnaire can have a richer language, because the questionnaires now converge to very simple questions that are the ones that the oracle can answer. So this is why we focus on the oracle. So this is the state-of-the-art oracle that is used in previous work. As I said, this is the oracle that is used to train most of the questionnaires that have been developed, that have been proposed. So in this model, an embedding of the question that we can see here on the right is the question, is it a vase, is obtained using an LSTM. Then the model receives the ground truth category of the referent, of the target object. Here it's a vase, but it can be a person, a sandwich, as we saw before, anything that you can think of being in a picture taken by a person. It also receives the spatial coordinates that the target has in the image. So what's the location of that target objects? These three embeddings are concatenated and scaled with a multi-layer perceptron. Notice that this model does not have access to the image. So the object category is just the category that says it's a vase. See? It does not have access to a crop of the target, and also not to the whole image. And it doesn't have access to the dialog history either. So what was said before in the dialog. And this is, so these features were the developers of this model tried to add these other features like the dialog history and the image. And in fact, they decreased the performance of the oracle, the accuracy of this yes-no answer. So they decided to go for this model. So one of the things that also motivate this work is that when we analyze the performance of the oracle, we see that the total accuracy is around 76% for this binary classification. However, we notice that for different types of questions, such as category questions, a category question is one that asks, for instance, is it a sandwich? Yes, it's talking about the category of the object. The accuracy there is very high, it's 93%, but remember that the model is receiving the ground truth of the category that is annotated in the MS COCO dataset. So this is why the accuracy is high. But if we look at some other kinds of questions, some of these may combine different characteristics. So it could be spatial and category. What we put in each of the different types are, for instance, if it includes the category and spatial, we count it twice, the question. So here, Spatial is the largest source of errors for this model that I showed and this data set. Why the largest source of errors? Because these questions are very frequent also, right? Because there are other kinds of questions in which the model performs worse, like the size, but size questions such as is it small are less frequent. So spatial questions, as we saw, are the ones talking about the position of the referent object. Color questions also are not, the performance is low, and so this is to be expected. In fact, we expected more or less chance answer in the color because the system has no access to the crop of the target. So to the color, it doesn't see the color, but it seems that color is correlated with some other, for instance, with the category, bananas are yellow. So it's not chance what we see there. So the first thing that we did, like our first experiment, was to replace the category of the object with the crop of the target. Also thinking that in MS Coco we have the gold truth labels, but in other photos we don't have that. So to see what was the performance if we just made this small replacement. And well, if you see the overall accuracy here, what we did was to make the general model worse, right? So the easy thing to do in these cases is to make a model that performs worse. So we had 76 before, and we have 72 now. But what is interesting to see here is that there are some kinds of questions like color that improves, because now the system at least has access to the actual color of the thing. And well, also we see that the category questions perform worse, and that's to be expected because we are removing the ground truth target there. So that was the first experiment. However, we wanted to have a better oracle. So what we did was to take LXMERT, the multimodal state-of-the-art transformer, for the oracle, and we thought how to adapt that for the oracle task. So LXMERT is used for several tasks in language and vision, but in particular, it is targeted towards visual question answering, not for answering referential questions. In visual question answering, the questions are not about a particular referent in an image. For instance, if for this image we ask, what color are these people wearing? We could answer white, but we could also answer gray, red, and black, because there are other peoples in that image, right? So we had to decide, in order to answer a question about a particular referent, we had to decide how to modify this architecture so that we could represent the referent and tell LXMERT that the question was about that particular referent. Yes, what is the target wearing? What color is the target wearing in this case? It is white. It is not red. So what we did is, as LXMERT gets 36 regions from the image in order to segment this image, and these regions are supposed to be ordered by saliency, so the things that are first are more are usually more objects. And like the 36 region that you see here are the letters in the publicity in the back of the match there. So this last region is supposed to be not so important. So we replace that region with the representation of the target. And we mark that region with, we tried different strategies like multiplying with scalar and other things. And then LXMERT processes the visual regions and the question as usual, thanks to self and cross attention layers. And the output corresponding to the spatial token CLS is given to an MLP to obtain the answer for that question. We consider two versions of LXMERT, one in which LXMERT is pre-trained on several multimodal tasks, and another in which LXMERT is instead trained from scratch on our task. So LXMERT brings an important boost in the accuracy. The one trained from scratch outperforms the LSTM-based model on all types of questions, except for the category questions, and the improvement is even more consistent with the pre-trained model. So the pre-trained model, it brings an improvement. Also, one of the intuitions there is that it has access to a larger vocabulary. And although the structure of guess what is quite simple, the lexical diversity that you see when people talk about the world and about natural images is very large. So here, we also improved the spatial questions that were the ones that we were more interested in. However, these spatial questions were still with this model a large source of errors. So we decided to zoom into them. And one thing that is interesting is that not all spatial questions are the same. Some questions, like the one that we have here on the left, with the basis, focus only on specific objects. Others, like the one in the middle, that we call relational, establish a relation between different objects in the image, while others questions refer to a group of similar entities, like the one with the giraffes. So in this paper, we proposed a fine-grained classification of spatial questions into 4 groups: the group type, the relational type, the absolute type, and other type. For instance, some examples is for the group is it among the 4 women? For the relational, is it the pen behind the PC? Identifying here 2 noun phrases, pen and PC, and we used the stanza part of speech tagger to identify these noun phrases and a preposition between them. We also used the same part of speech tagger to identify group questions and identify when a number was present there. We included in this kind of questions those that contain a number, like an ordinal, like here, like 4 women, and also those questions that refer to order inside the group, like the second woman could be in a group of 4 women. For the absolute questions, we consider some location word like left, right, top, bottom, foreground, background. Consider the different axes that people can refer to spatially. And in the other group, we had a mixture of things. One of the things that got our attention were affordability questions. So here, can you sleep on it? If you're talking about a bed, it's like people imagining what you could do with the things that are in the picture. So something also that is interesting about this classification, if you look from top to bottom, is that the group type can contain 2+, so 2, 3, 4 or more things that share some property. The relational are usually between 2 objects, while the absolute is talking about 1 object, while the other is talking about 0 objects. So some imaginary object for the affordability questions, right? So having made this observation about the different kinds of objects related to the different kinds of spatial questions, we did an attention analysis on LXMERT. And we saw that, for instance, in this example, is it the bus on the left? The answer to this question is no, because the target, in fact, was not a bus. But the interesting thing is that in the region of the bus on the left, there is a higher attention of 0.13. And then when we move to relational questions, we see that there is attention put into, in this case, the question is it the boat next to a car? And there is attention on the boat here with a 0.12, a large boat that is near a car. There is attention on the car, and there is attention also on the target, which makes sense in order to compare to see whether it was that boat. The answer is also no here because it's a different boat. And also on group questions, we see a similar behavior. We are still working on this analysis to consider and counting how many regions LXMERT is focusing attention on, to see whether we could use these attentions further into a model of adding history also to the oracle. And that's what we are currently working on. So if you have any comments or any suggestions, because sometimes, so these examples that I showed you here are what we expect, but sometimes we find that the regions that the system is focusing the attention in are not the ones that are to be expected. So focusing on these different kinds of questions, yeah.
Oh yeah, I just had a low level question. So like how exactly were these attention scores calculated? Like was it like the last layer of LXMERT, or was it like some kind of gradient sort of thing like GradCam?
So the last layer, the CLS token, that's what we are looking at. But if you have some other suggestions, there are many things that we could look at, yeah, as you say, yeah.
Mm-hmm. Okay, yeah. Thanks, yeah.
Thank you. Okay, so here what we did is just to analyze whether the different kinds of spatial questions were harder, were difficult in the same way for the model. And in fact, absolute questions seem to be the easier. Well, but something that surprised us is that the larger improvement was on relational questions. Because relational questions are hard. I mean, you need to identify both objects, and you need also to interpret different kinds of relation that can be in front, like behind. So there are many propositions with different meanings, and there was a large improvement in those. The most difficult, so the lowest accuracy is on group questions. We also observed, I have not included it in the slides, but we observed that with lower numbers of groups, it was behaving better than with larger numbers. And we thought whether this could be related to a cognitive limitation that people usually when they identify, like when they see 4 things or 5 things, they can identify the number without counting. And when you go over 5, people need to count to see how many there are. So whether LXMERT was able to do this initial, like recognizing visually the number, but not counting. So, because there were still all these errors, we did a manual analysis of 20% of LXMERT errors on spatial questions. We found that the absolute and group questions have more errors related to the missing dialogue history compared to relational questions. Around half of the errors are due to this lack of information. For instance, here on question number 4, this could be answered with yes if it was asked at the beginning of the dialogue, because middle would refer to the middle of the image. But in this case, the answer is no, due to the dialogue history, since middle refers to the middle of the group of oranges. So the answer in the beginning of the dialogue, or the answer considering the dialogue history, changes from so in the beginning of the dialogue, it could be yes, and then it changes. So in the beginning of the dialogue, it could be no, and then it changes to yes because of this. Okay, so to wrap up this part of the talk, we have adapted LXMERT to play the Oracle agent for the Guess What game, outperforming the widely used baseline by a large extent. In particular, we focused on spatial questions in our more detailed analysis. Although LXMERT significantly improves over the baseline, spatial questions remain a large source of errors for the Oracle. We proposed a more fine-grained classification for spatial questions into 3 subtypes, and we released a new annotation for the Guess What test set. We found that the relational and group questions are harder than the absolute questions, and that different spatial questions require focus on different numbers of objects. We also did an initial analysis of how LXMERT attention differs for each spatial question subtype. And finally, thanks to a manual error analysis on a subset of the questions, we highlighted the importance of having access to the dialogue history in order to answer some of the spatial questions. Our current models only receive the question to be answered as the input. Also, our source code for this work is available in that link and in the paper. So now, unless there are any questions, I will proceed with the second part of the talk. This part is based on a paper that I will be presenting next week at EACL, and is joint work with Patrick Blackburn. And so this is a quite different part of the talk. So this is a position paper, and it's a position paper that also does a lot of reviewing of previous work and the state of the art. And it's an opinion piece. So many of the things that I will present here are my view or our view with Patrick, and with I'm trying to represent a community like the special interest group dialogue of the ACL, and also a group that is working on semantics and pragmatics of dialogue. So this is a harder talk to make, a more difficult part to present, but I thought it was my duty to plant this seed and start putting these things under discussion to maybe have raise some discussion in the community here about these topics. So we've been talking now in the previous part about perceptual grounding. However, some people argue that there are other kinds of grounding that are more important or also important for natural language understanding. As David DeVol would say, that is one of the related works that I will mention later. Human meaning attributions do not rely on the accurate perceptions and perfect memory sought by perceptual grounding. Because we humans, we don't have perfect memory and accurate perception, but they rely on collaborative grounding. Collaborative grounding is a negotiation process in which language speakers coordinate their perceptual memories and their common ground with other members of their communities. Collaborative grounding and perceptual grounding are two different but complementary types of grounding. So let me now switch to collaborative grounding, and I give here some basic definitions. By common ground, I mean the commitments that the dialogue partners have implicitly or explicitly agreed upon. And by common ground, I mean those commitments, the one that the dialogue partners have agreed upon. And by collaborative grounding, I refer to the process of seeking and providing incremental evidence of mutual understanding and misunderstandings through dialogue. This process is done by positive grounding acts, such as acknowledgements, head nods, and continued attention. And also through negative grounding acts, such as clarification requests or negations or other kinds that we will see in this part of the talk. I come back here to the two big picture questions with which I started this talk. So in the last part, I talked about perceptual grounding, and now I will talk about the consequences of systems not being able to do collaborative grounding. We think that one of such consequences is highlighted by this bridge blue question that I pose here. Why do dialogue systems handle errors in a non-human-like way? Our central claim related to this question is that being able to recover from errors collaboratively is a key ingredient of the ability to ground. If this ability is missing, a sense of commitments being brushed aside arises. And let me give you an example. Let me illustrate that. What I mean with commitments being brushed aside. Here, Carlos, who is a human, a person, is interacting with BlenderBot. BlenderBot is a state-of-the-art chatbot developed by Facebook. And Carlos starts by saying, "Do you know Blender?" After reading BlenderBot's response, that is, "Yes, I've used it a little bit. I'm not very good at it though," Carlos realizes the ambiguity in his initial question and clarifies, "But I don't mean the 3D software." In this turn, he's attempting what the collaborative grounding literature calls a negative grounding act. A negative grounding act signals that something needs to be negotiated collaboratively before the dialogue partners can commit to it. BlenderBot answers to that, "Oh, I see," which sounds like a positive grounding act. This makes us think that he's handling the mistake as a human would do, and it even adds, "Yes, I know a little bit about it. What do you like to do with it?" We may assign a playful and sarcastic intention to this response since BlenderBot is what Carlos means by Blender. As Emily and Alexander like to say, human beings are very willing to attribute intentions to all language. However, Carlos tries to make sure that the correct meaning of Blender got into the common ground by saying, "I mean Blender, the chatbot, have you used it?" BlenderBot responds, "Oh yes, I have used it. I like to use it to make 3D models." We may feel here that BlenderBot is playing the fool, but in fact it isn't. BlenderBot is showing what we call in the collaborative grounding literature misunderstanding recognitions market. that BlenderBot has seen in its Reddit training data. These markers are like here in this dialog, oh, I see, and oh, yes. And they make us think that the error was handled correctly, but the follow-up turns show that it wasn't. This is another example of the text-based adventure AI dungeon, which claims to be based on GPT-3. In this example, we intentionally generate a clarification request to see whether the model can maintain consistency. So the system starts by saying, you open your purse and you find 7 golden coins, which is good since you only plan to steal a little. And our clarification request is how many coins are there in the purse, and we utter it after reading that there were 7 golden coins. So here the system answers, you count the coins and find that you have 81 coins, which is good since you only plan to steal a little. When we detect the inconsistency, first the system said that there were 7 golden coins, and now that there are 81, we prompt Dungeon AI with a negative rounding act. But before you said that there were only 7, how many are there really? This makes the inconsistency with the previous turn explicit. That is the strategy. In fact, we are offering to negotiate. We are doing collaborative grounding here. But the model ignores the negative act and talks about something else. We posed this question several times, but the model never tried to negotiate inconsistency. What we mean here with negotiating consistency, for example, the model could have said, there are 81 coins. I only saw some of them before. And that's perfectly right for a human conversation. It is well known that neural generative models generate contradictions. There is quite a lot of work trying to avoid these contradictions, but we think that this approach of avoiding contradictions misses the crucial fact about dialogue. Dialogue is not about avoiding contradictions. It is about being able to recover from them collaboratively. E. Clark, that works on language acquisition, argues that collaborative grounding offers a way of placing a new piece of language at the center of joint attention of the baby and her caregiver. The joint attention denotes the part of the common ground that is currently under discussion. Babies around 1 year old that make one-word sentences have been shown to perform negative grounding acts in order to repair a request that they made. For example, if they said doll, whose intention was to get the doll, and it was misunderstood by an adult, babies tend to repair with the negative grounding act, even when the request was satisfied. Maybe the frustrated adult took all the toys and gave all of them to the baby, yet the baby takes the doll and says, doll. In other words, they care that the intention is understood, not only satisfied, not only getting the doll, but realizing that what the baby said was properly understood by the adult. Ironically, our first suggestion here for moving forward is to look backwards, to read pre-deep learning work on collaborative grounding for dialogue. I will not be able to talk about all this work here, and we refer you to our paper where we summarize this work, which our paper has these 115 references, including some on human language acquisition that I briefly mentioned before. I will just mention David Trump and his computational theory of grounding, Verena Rieser and her dialog systems from Wizard of Oz data, David DeVold and his societal grounding, Raquel Fernandez and her theory of non-sentential utterances, Matthew Perver and his analysis of clarification requests, Christine Hose and her take on incrementality in dialogue, David Schlangen and his take on incrementality in dialogue, Amanda Stent and her view on multimodal dialogue, Matthew Stone and his rationality in grounding, Svetlana Stoyanchev and her natural clarification questions, Staffan Larsson and his grounding as a side effect of grounding, Joelle Pinot and her work on how not to evaluate your dialogue system that I recommend a lot when I do area sharing for the dialogue and interactive systems track at ACL, Alexander Kohler and his situated natural language generation, and last but not least, Julia Hirschberg and her long line of work taking seriously the relation between the dialogue participants. Our second recommendation is related to the fact that most previous work trying to model dialogue history just take the whole dialogue and concatenate it. One suggestion that we make is to model the dialogue history in the visual modality, maybe in an interpretable way. Here is a simple example based on one of the errors that I showed before with LXMERT. Each answer to a question could be seen as modifying the visual input, as if it was modifying the attention. The answer to, is it a fruit, restricts the joint attention to the fruits. For example, like this. The answer to, is it an orange, restricts the joint attention to the oranges. With this joint attention, the question, is it in the middle, can be correctly answered with no, because the orange is not in the middle. If the joint attention is not considered, is it in the middle, will be wrongly answered like LXMERT does, because the intended referent is indeed in the middle of the image, as we saw before. This is a simple example of a very complex phenomenon. In this EACL paper, we reviewed datasets that contain collaborative grounding phenomena grounded in different modalities like hearing, touching, moving, and seeing. And in our forthcoming NACL paper, NACL 2021, we investigate how to identify and characterize grounding acts grounded in different modalities. Our third suggestion is to focus on error recovery, not error avoidance, and to learn from the negative grounding acts. Our point here is that humans cannot adapt and ground collaboratively if a dialogue system fails to expose its own limitations. Limitations in dialogue can arise due to gaps in grammatical coverage, an unexpected narrow domain vocabulary, a lack of common sense. We are not claiming that all this needs to be solved in order to do meaningful dialogue, but that the dialogue systems need to have enough social common sense, such as not to hide their own limitations. So, two things to ask yourself is, does your data contain positive and negative grounding acts that expose the system limitations? Does your system learn, even if the data set contains those? Then does the system show that behavior? Can it learn it from the data in order to recover from an error? The catch here is that in order to be able to learn these negative grounding acts, we will need manual annotations, because negative grounding acts are not marked by some particular lexemes. They are not always questions, so they are not lexicalized. So one of the things that we proposed in order to obtain annotations of negative grounding acts is to take a test that was originally proposed by Gavstil in 2003 to distinguish negative grounding acts from other terms in dialogue, by using the explicit acknowledgement OK. For example, in this dialog, Gapstil test predicts that the lieutenant term is not a negative grounding act because it can be preceded by OK without changing its meaning. With this question, the lieutenant is completely uptaking the certain information and moving to the next most pressing topic in the conversation, who is heard. What Gapstil says is that it doesn't make sense to explicitly acknowledge some contribution that we are going to clarify right after, right? Here, since Matthew's question is about the meaning of the word Gandalf, it cannot be comfortably, preceded by an acknowledgement. And then Matthew's question is a negative grounding act here in this example. However, there is a problem with this test. It is useful, but it labels some things as non-negative grounding acts when they actually are. This is an example extracted from the map task corpus. In this corpus, there is a giver that is giving instruction, and then that has this map that you can see here, and there is a follower that has the same map, but it doesn't have the dotted path written, and it has to reproduce it by following the instructions given by the giver. Suppose here that the follower has drawn the line until the blue cross that we see here, but not the rest of the line. And then the giver says, I want you to go towards the green bay and make a slight diagonal line sloping to the right. In the corpus, the follower actually says what we see here as B with explicit OK. Gapstil test then predicts that this is not a negative grounding act, but this is wrong because the follower is trying to understand the instruction. He has not moved to a new topic. He's trying to collaboratively ground the instruction. He has heard, he has understood all the words and identified all the reference, but he has not actually executed the instruction. What is going on is that this OK is ambiguous. So in the carpenter example, the giver acknowledged that in level 3, in this level 3 that we see here, but he could still clarify in level 4. We say that there are many different meanings to OK. Here we show 4 different meanings grounded in different modalities. Level 1 is related to the channel of the communication. Level 2 is related to hearing. Level 3 here is related to seeing. And the last one, if we interpret it in the map task corpus, is related to drawing, but it can be related to a different modality in a different data set. Here are examples of different clarification requests that can be asked, different negative grounding acts that can be done as a clarification request for each level. So, for instance, the giver cannot say, okay, I did it, I draw it, and then ask, do you want me to go above the carpenter? So, in the paper that I mentioned, NACO, we proposed this methodology based on this modified test that I just showed you in order to identify annotations for grounding acts, for instance, using crowdsourcing. We also propose how to define the different levels according to the modalities that are relevant for the dialogue situated in the different tasks. And this is going to be published in the special theme, New Challenges in NLP. So to finish, our last recommendation our fourth and last recommendation, is motivated by a recent paper by a group of very well-known authors. They give a detailed description of the milestone that must be passed in order to achieve what they call truly contextual natural language understanding. They argue that we are currently close to the written word milestone, the next milestone being perception, the following one embodiment, with the final one being social. However, given this argument that we've made and these non-human errors that system exhibit, the state-of-the-art system exhibit, we believe that maybe the community could consider not living social till last, as the last thing that has to be handled by the NLP community. So just to summarize and to give to get the discussion started, I wanted to share with you some points made by the reviewers of this EACL paper that I just presented to you. So reviewer one, and these are the positive points, and I will also finish with the negative points so that we can get the discussion started, or maybe it will motivate some questions. So here, Erwan considers that the paper contributes a stimulating argument that current approaches to dialogue systems are not addressing. In particular, in other parts of the review is talking about deep learning approaches, and that this is a fundamental skill of human dialogue, that is collaborative grounding. R2 says that for those new in the field, such paper could guide further research, and it could be an overview of previous work. So this is what we had in mind when we decided to write this paper, and we were happy to receive these reviews. So reviewer number 3 says that almost all published work on dialogue systems is written from the perspective treating dialogue just like another machine learning problem. For instance, something that happens to me many times when I review papers is that those systems that just concatenate the whole dialogue history, maybe just forgetting which was the speaker and which was the hearer. If you are thinking about the data set in a multi-party meeting with many people, so what's the meaning of you there? I mean, who is you referring to? And there is a lot of discussion, as this reviewer says, in the community on this kind of phenomena. In fact, there is a paper that is called "Who is You?" over the last 50 years. That is almost not cited by this community now. And reviewer 4 says that it's interesting to this paper that characterizes collaborative grounding and suggests some requirements describing how to proceed. But most interestingly are usually the negative comments that are, for instance, what happens with the industry task-oriented dialogue systems right now. So in those system, engineers are hard coding the grounding strategies. So this reviewer was asking, how do we see this knowledge that engineers are putting inside these systems? Also, similarly as human-computer interaction designers do when they design with grounding in mind. Also, reviewer 2 says that this is not so new information for senior researchers. Reviewer 3 says that although we acknowledge that communicative grounding and perceptual grounding are different phenomena, we fall into the trap of not clearly distinguishing the two. And we agree with reviewer 3 there, and we think more work is needed to see how these two things interact. And reviewer 4 says that there's a lot to do in communicative grounding, but he, instead of starting from two stupid artificial systems that will naturally fail in meeting and explaining most natural collaborative grounding behavior, he thinks that we should base our research on YouTube data. So these stupid systems that I showed are the state of the art right now. And with this, I just leave there our initial questions. We have posed a lot of questions in this part of the talk and not given concrete answers. And we feel these are issues that need more attention, and that the dialogue and interactive systems community will benefit from making them questions under discussion. And just to repeat, our central claim is that current dialogue systems try to avoid mistakes at all costs. And this approach misses the key point that errors are a crucial mechanism in dialogue, for it is the ability to recover from them that makes dialogue such a robust process. Thank you for listening.
Thank you so much. Do we have any questions from the audience? I had one question, which I was wondering, when we're talking about negative grounding acts, do we have a sense of kind of their prevalence, both in like naturally occurring conversations in different domains, as well as in like a corpus of the kind of utterances that are generated by like a dialogue, like a designed dialogue bot?
Yes, so as you hinted at, this changes from domain to domain. So there are some domains in which you have like 10% of the turns are negative grounding acts. For instance, if you have dialogue in which people are co-situated and they are doing a task together, like a physical task, like building something, for instance, because they have to make sure what the other person said, and also there is immediate feedback whether they misunderstood an instruction, so maybe they just clarify before. If this is more like chit chat or open domain dialogue, clarifications are much lower, because also kind of clarifying something, asking for a clarification request is something that is not as polite. Is that you are saying the other person what you said was not completely clear, so I have to ask a question. So there are these politeness pressures that are inhibiting some clarification requests that maybe were needed, but people just, if they didn't need to understand completely what was said, they just let it go. So yeah, the percentage, it goes from 1% of the turns to 10%, or maybe up to 20%. If this is a critical task, that it may have bad consequences, like life-threatening consequences, if you don't really understand what the other person meant. Yeah, that was a very interesting question. Thank you.
And another question from Kalpesh, who had to go to a class. He was asking, do you think that the issues with AI Dungeon are due to GPT-3 not being explicitly trained on a lot of dialogue?
Yes, it could be. So that's why I thought it was also interesting to analyze the BlenderBot example. So BlenderBot is trained on Reddit data and a lot of dialogue data with similar mechanisms as the one that GPT-3 is trained with. But yes, the Dungeon AI does not recognize when you make a negative rounding act. Blender recognizes that it was a negative rounding act and answers with something that looks like an answer to a negative rounding act, but that misses the whole point of so trying to, committing to what it said before. Yeah.
Yeah, it sounds like we have to take baby steps just to make it a little bit better. But great. If there aren't any other questions, I want to also let you take a break before your first meeting, which I think is at 1:30 with me. But yeah, in that case, please unmute and let's thank the speaker. Thank you so much, Luciana, for visiting today.
Thank you.